Welcome. Welcome. My name is Per, and I love to talk about automated testing. In fact, I can talk about it all day, but now I have about 45 minutes, so let's make the best out of that. I think automated tests is one of the most important tools that we have as software developers, because it gives us confidence when we add new features and fix bugs. And it gives us freedom when we have new, wild and crazy ideas. Because when our automated tests are all green after adding, fixing, trying out, then our software is, for some definition of the word, correct. But, green tests aren't very interesting. This is a talk about failures. And while that sounds a bit depressing, the upside is that it's about good failures. And I will talk about good failures versus not good failures in a minute. I would also like to talk a little bit about going the extra mile. Because we all know that for an automated test to be meaningful, it needs to pass when our software does what it is expected to do. And it must fail if the software doesn't do what it's expected to do. But I don't want us to stop there. I don't want us to stop when the test fails. I also want us to study the failure and make sure that the failure is as informative and helpful and useful as possible. Because then I think it's a good failure. Good failures is what we're going to talk about. So, good failures lead to useful automated tests. And what is the opposite? Well, the opposite is, of course, bad failures. And then you would think that bad failures lead to the opposite of useful automated tests, which would be useless automated tests. But I think they lead to more than that. I think they become a burden. So bad failures results in a test suite that is a burden. Because when you have bad failures, you will hear and probably talk yourself about things like, the feature is done, I just need to fix a lot of tests that are failing, or those damn tests are failing again on the build server, we don't know why, so let's disable them. And when you have that negative attitude, or when you get that negative attitude from the tests, and when you start to disable tests, then you diminish the value of your test suite. And you actually create a situation where the test suite gives you a false sense of security. And now it's definitely a burden or a liability. And we don't want to end up there. So no bad failures. So, a scenario. Imagine it's release day. How many of you do continuous delivery? Oh, nice. So for you, this is just another regular day, right? But imagine that it's it's still a special release day, right? It's Friday or something. And for some reason, unknown to us here today, you have pushed some last-minute fixes. Has that happened? Never, ever. And you and your team are sitting in front of the screen and you're watching the build server dutifully building the release. And if for some reason it takes longer than usual, as it does on release day, but it's up to 63% and it looks good, and then bam, something happens. The build fails. It's all red, all over the place. So you open up the actual build, you notice that there is a test error, or there are actually multiple test errors. So you pull up the test log, and you see this. Expected true, but was false. What do we do from here? Well, you have some more context in this. You have a test name, don't you? This is test 1 failing. No, seriously, you don't have that. You have something else. It should work. And this is even worse, because this test name is mocking us. We have a red build, we have a text that says it should be true, it's not, and then the test name says, haha, it should work, but it's not. Hopefully, you have never done this, right? No. Good. So you have something like it should be empty after pushing the popping because this was a stack test, and the empty logic apparently didn't work. But we're not very much wiser here because we know that something about the empty logic is wrong, but we don't really know what. We just know it's wrong. I don't think this is a good failure. I think this is a bad failure. I want us to optimize for problem discovery, because in the situation we just had, we had a test failure on the build server. And what is the first thing that we need to do? Well, we need to run the test locally, right, on our dev machine. And hopefully it will fail there as well. If it doesn't fail, then we're screwed, because now we have an intermittent test failure, or we have a test that depends on the environment, which obviously was different between the build server and our machine. This will be very hard to fix. We start up the debugger, and now we've lost, because this is very time consuming. And if you have a complex system, which we do nowadays with microservices and whatnot, then debugging might be very hard. Maybe we add some print statements, Who here has forgotten those print statements in the code, and then you have them, popping up everywhere? Not me, of course. And then perhaps we write some more tests to pinpoint the problem. And then, now we know what the failure was. Now we can fix it. So this long chain where we play detective, we pull out our detective's hat and we start the debugger and do a lot of investigation. But why not test failure and build server and now I know what the failure is. This is what we want to achieve, to get immediate knowledge about the problem in our code, because then we can be really quick with the fix and actually go home to our families on the Friday evening and not spend the entire weekend debugging things. So we spend a lot of time thinking about how software can make our lives easier, right? My goal here today is to inspire you to do the same with your automated test. That is, to think about how they can make your life, or your development, your software development life easier. That won't do much for your personal life, of course. And what follows here are some of my mistakes. Maybe you'll recognize some, maybe not, and the patterns that I use to fix them. So, there were test failures on the build server. We need to fix them. As you will see, I use NUnit in my examples. This is not an NUnit talk. It just happens to be the framework that I use the most, and it's nice to be consistent throughout the talk. But you can apply what I talk about here to just about any test framework, right? So if you use MS Test or whatever, that will work as well. So our first failure wasn't actually the one before, because that was totally made up. This is totally real. So our first failure is this. It says English numbers, text conversion, hyphenates, words. So we have something that converts numbers into text, and it should hyphenate. But it doesn't. Expect it true to be false. Is this a good failure or a bad failure? Bad failure. Let's look at the test. We pass in 42 to our English numbers describe method. And then we compare that we get 42. And this fails. What is the problem here? Anyone? I don't know what I get, because I do the comparison and it works. Obviously it recognized that the actual wasn't 42 with a hyphen. So I do the comparison myself, and then I give the result of the comparison to the test framework. And the test framework can only say, well, okay, you gave me false, and I expected it to be true. So there's nothing it can do. So how do we fix this? Anyone? assert that actual is equal to 42. So we hand the actual value to the test framework and the expected value to the test framework. And now the failure is much more useful, infinitely more useful, because now NUnit tells us that the expected was 42 with a hyphen, whereas the actual value was 42 without the hyphen. So now we know exactly where the problem is. Whereas before, it could have been anything. We might have gotten an empty string for all I know. So this is way more useful. And now we can fix this easily with little effort. So one done. How about the next? The next failure is apparently a test data provider failure. You know, test data providers are good because they provide us with test data. They're only useful if they provide us with useful test data, so it makes sense to have tests on them, right? Do you have tests on your test data providers? I take that as a yes. Good. Expected true to be false. Good or bad failure? Bad. Is this the same problem? We have assert true, like we had before, but now we have, because the test data provider is supposed to create a valid person, it says so right there. And then we have a isValid method on the person class in our domain model, and there's not much we can do here. We can only test if isValid returns true or false, right? We could, of course, write assert that person is valid is equal to true, but that would be equally useless as this. So the problem here appears to be that all we get is true or false, and we cannot really test anything beyond that. How do we solve this? Any suggestions? Yes? Break it up in smaller pieces. That's one idea. So you would test separate parts of the validness. Okay, good. Makes sense. Exception from the isValid method. Who said this? Okay, so I can look at the right person. You mean from the isValid method? Okay. Okay. Anything else? Yeah, we can probably talk about that forever. So what I did was just add an out parameter to isValid. So I say that isValid actually returns true or false, but it also provides information about the reason in case it's not valid. And then I can just put that reason as the last parameter to assert true, and all of a sudden I still get accepted true to be what was false, but I also see invalid age. So apparently our test data provider failed to create test data with valid age. Perhaps someone added constraints to the age, but forgot to update the test data provider. And as you said, there are different ways to solve this. Also note the very nice feature in C#7 where we can just inline our out variables. Very, very nice. What I've talked about here is something that I think about as Boolean reduction or lossy compression. Because when you have lossy compression, you compress something, but when you then decompress it, take it back, you won't get all the details. And with Boolean reduction, we take something, the state of a person, or two values, and then we just compress them together to true or false. But then we can't backtrack. We can't go back from there to know what actually was the reason for it being true, or the reason for it being false. And in 99.99% of the cases, I would say that we are always interested in the why. Why did it fail or success? Why was it true? Why was it false? And we must make sure that it's visible, both in the tests, as in the first example, where we want the test to fail with all possible details, but also in the domain model. So in this case, my test led me to refactor the domain model a bit so that I can get more information out of this valid method. And then you could argue that well, you shouldn't do that because it was only a test, but it's useful in other contexts as well in the production. Apparently the failures never stop, right? Our next failure on the build server is this. RGB colors include G, which makes sense, you know. And again, the same bad error message. Let's look at this. We have another assert true. We all know that is not good by now. But other than that, the test it reads quite well. We say that assert true that colors any color there should be a color that starts with the G, right? Any color should start with G. The problem here is, of course, the same as before, that we pass true or false to the test framework, so it cannot really do anything useful. But luckily for us, the test framework has actually support for more complex assertions than just true or false. So in the case of NUnit, and of course this varies very much with the test framework that you use. So in NUnit, I can just say assert that colors RGB has one that starts with G. And now our test is much more useful because we see that we should have one starting with the G, but apparently the RGB property returns red, yellow, and blue. And we immediately know what the problem is. Someone swapped green and yellow. Sometimes you end up in a situation where you underuse the assertion framework. That was what that was about. Most assertion frameworks are extremely capable and have very many different kinds of assertions that can help us write good tests with good and explicit failures. You should also know that, and you probably know this, but test framework and assertion framework are two different things. I've talked about test framework before, but the test framework is really only about discovering the tests and running the tests. The assertion framework is about asserting things, right? And you can often combine a test framework with different assertion frameworks. So with NUnit, for example, you can use NUnit as your test framework, and then use a completely different assertion framework that has good assertions, that helps you write good tests. And many assertion frameworks can also be extended, as we will see a little bit later, so you can write even better assertions that better tell you why things fail. So I recommend you to explore different assertion frameworks. I will show one example of that later, to find the one that best suits your need. So let's look at a more interesting failure on a real server. This is apparently also related to RGB, and in fact it's apparently one more test that tested approximately the same thing. I don't know why we have multiple tests that test the same thing, but apparently the test author was very enthusiastic. So we have colors are RGB, and we get some information here. We get that the values differ at index 1, and it expected green but was yellow. And it helpfully tells us that the difference between green and yellow starts at the first letter, which is, new information. Is this good or bad? Good? So in the corner, yeah. I think it could be better. First of all, I think there's some noise here. I'm not very much interested in the fact that the expected appears to be an array, while the actual is some generated field in a generated class. This is just noise. I also think that the fact that green and yellow differs on the first letter is a bit noisy. But most important, I don't know anything about the remaining values, right? From this I only know that they differ at index 1. Do they differ at index 2 as well? I don't know. I get very little context out of this. The test in itself looks quite innocent. We are using the test framework, right? Assert that colors RGB is equal to red, green, blue. But I think we can get a better failure out of this. And to do that, we have to experiment a bit and see what we can use. For example, one idea is to not use an equal check. Maybe it's important that we do an equal check. Maybe the order is important. Maybe it's not. But let's try the is equivalent to. And for some reason, NUnit is much more informative when we use equivalent to. Because now it really tells us that it expected red, green, blue, but was red, yellow, blue. And it tells us the missing one and the extra one. So if it's the case that we can use an equivalence check rather than an equal check, then we get a much better failure, I think. I said before that you can use different assertion frameworks. I tried one called Fluent Assertions. It's just a NuGet package you can import, and it works well with NUnit. And it it has a different syntax, which is quite nice. Colors RGB should equal red, green, blue. Also less boilerplate, because I don't have to type the new brackets and color braces, because this is a params array. And fluent assertions will tell me that the expected was red, green, blue, the actual was red, yellow, blue, and the different in this one. So here I have an equal check, right? Order matters, and I get a much more useful error message. So by just experimenting a bit and trying out different options here, I get, in my opinion, much more useful test failure. Fail with rich context is how I think about this. We want our test failure to be as informative as possible. Quite often when I see a test failure, I ask the question, well, what about the things around it? In which context does this failure exist? And I want my tests to answer that. To do that, I need to experiment with different ways of writing the test case and possibly different types of assertion. And of course, sometimes, if I don't find the appropriate assertion, then I will have to use a custom message. Most assertion frameworks support a custom failure message, as the one we saw before with is valid. This is sort of a last-minute resort because it's a little bit duplication, but that might be our only way out. This is, of course, most important for high-level tests, because if you have a very, very pointed unit test, then from the test name and the failure, you're likely to figure out what went wrong anyway. But imagine that you have a UI test or API test or something like an integration test. Then the context is often very, very interesting to have. Otherwise, you will have a hard time figuring out what went wrong. Okay. Our next failure is it good or bad? Any good? Any takers for good? No? Bad? Yeah, 1, 2. The given key was not present in the dictionary. Perhaps .NET's most useless exception ever has annoyed me many times. I have no idea what went wrong. This gives me absolute zero information. Well, obviously there's some dictionary involved, but let's look at the test. What we have in top is actually the production code. So you just have to imagine that there's a separation in between here, production test. So apparently we have a map to English. It uses our English numbers describe method that we had before and maps the input array to a dictionary. And apparently someone put in a filter, possibly for test reasons, just, you know, unknown to us. We can use git blame to figure out why, but someone left some code in there that that excludes numbers 14 up. And then our test passes in 22, 32, and 42, and then just does a needle test for 42. And what is the problem here? Can you see it in the bottom? The problem is here. What happens when you index a dictionary like that in .NET and the key doesn't exist? Well, you get the exception that we saw before. So how do we fix this then? My first idea was, let's add an extension method. So we add the get or default extension method. I think it exists in all code bases all over the world. If the key doesn't exist, it just gives us default back, which is null in this case. And now we don't get the exception. We get expected 42, but was null. Is this good? No, it doesn't help me at all. So I need to try a different approach. What about this? I get my dictionary, then I transform my dictionary into a list. The thing here is that a dictionary is, as you know, an IEnumerable of key value pair, right? So just by doing toList, I get a list of the entries in the dictionary. Then I can say assert that entries does contain the key value pair 42, 42. And now I get a much more useful failure, because now I see that there should be 42, there was only 22 and 32. And now I know that something is happening above 32. Something is taking away those numbers. So I have a much better chance of figuring out what the problem is, if it wasn't obvious from the code, but you can imagine that there's a little bit more complex troubleshooting involved. I think of this as transform before assert. So I want to make the data that we're testing more assertion friendly. I want to apply transformation so that the data is good to assert on. And the need for this varies very much with the assertion framework. If you have a very primitive assertion framework, then this need might be pretty great. If you have a very capable assertion framework, then perhaps this need is also very small. You'll just have to see what you have to work with. Of course, we need to take the fail with rich context into consideration, because when we transform, we might also lose context. So there's a balance between, keeping as much information as possible and transforming data into something assertion friendly. So these two needs to be balanced. Okay. Next, test failure. Person filters is a class that filters persons. It should filter them by name. And it says expected 3, but was 1. Is this a good failure? No. It's almost as if all my failures are bad to begin with. Now, there's a lot of code here. Up here we have test data, right? So this belongs to the tests. Then we have our production code in the middle. This belongs to the person filters class. I have omitted something for some things just to fit it on one slide. We have our named method that takes persons and the name, and then it filters. And the problem appears to, I don't think that comment was in the code from the beginning, appears to be that it only looks at the first name. Our test is down here. It says, given our test persons, we filter out the one named Ross, and we expect the count to be 3, because we have Diana Ross, we have Bob Ross, and we have Ross Geller, right? Apparently, the failure told us that it was only 1, and we can see quite clearly that it's because the filtering only happens on the first name. But the test failure doesn't tell us that. The test failure forces us to go into the code and investigate. I don't like that. Luckily, NUnit has a wonderful assert that named Ross has count equal to 3, and you would think that gives us the information that we want, because it's built into the assertion framework. And that gives us expected property count equal to 3, which is, again, completely useless. So no help from NUnit there. No. What we need to do is something more creative. We need to use our transform before assert approach. If we say that we get our persons named Ross, and then we map them to their full names, using a small helper here. And then I say that full names should be equivalent to Bob Ross, Diana Ross, and Ross Geller. And note that I use is equivalent to, because we found earlier that is equal to is not that good. And now I have a much more useful failure. I see here that we have Ross Geller, we are missing Bob Ross and Diana Ross. And from this information, you can actually figure out that the problem is probably that it only looks on the first name and not the last names, directly from the failure. But it turns out that we can do even better, because there's a problem with this test, which I haven't talked about. Anyone can see the problem? Hint, it's very brittle. What happens if I add more test persons for another test, and one of those test persons happens to be named Ross? In that case, this test will fail, because it tests that we have exactly these persons named Ross in our test data. So it's brittle because it will probably fail with new test data. We don't want our tests to fail when we add new test data. So we can do better. We can actually use a different assertion. It's superset. Because in the previous case, we are actually interested in knowing that we filter on first name and on last name. We had Diana Ross and Bob Ross. They're testing both is redundant. They both have the same last name, so we can just verify on one of them. So if we say that the actual names should be a superset of Diana Ross or Ross Geller, I mean Diana Ross and Ross Geller should be in the set of full names. And our failure message is equally good as before. We are missing Diana Ross here, but now we won't fail with new test data. Okay, so we have a much more robust test. But we can actually do even better. We can take this one step further, because there is a problem here. This is a little bit of a sheet test. Anyone? What does this? Someone down there? Yeah. True. So what you said was that we could have test data unique for this test. And that is true, because when we have shared test data, then we have sort of hidden dependencies between tests. So yes, that would solve the brittleness problem, for sure. Okay, good point. That was not what I was thinking about now. Now, the problem I was thinking about is that we actually test two things in one test. We test that we filter on first name, and we test that we filter on last name. We could separate that into two tests. One that verifies that we filter on first name and one on last name. Then we would have a success in the first name test and a failure in the last name test, and it would be much more obvious to us what the problem was. What we had before was numeric reduction, and numeric reduction is almost as bad as Boolean reduction. It's a little bit better because there are more numbers than Booleans, but it's not very useful. It doesn't help us when we reduce things to numbers, to counts. And it can lead to brittle tests, as we saw when we add new test data, unless we use test data local to the test, of course. What we did was that we confused total count with occurrences. I tested that we had 3 items in the beginning, but that was not really what I was after. It was after occurrences of persons matched on first or last name. Another thing was the single test responsibility principle, which states that a test should test a single thing. Or more specifically, that a test should fail for a single reason. But in our case, we had a test that would fail for 2 different reasons. First name, last name, filtering problem. Okay? So whenever you have a test, you should ask yourself, in which situations would this test fail? What kind of problems in my software would cause this test to fail? And if the answer is, a handful of things, then it might be a good idea to break up the test. This is not about the number of assertions. Someone may have told you at some point in time that you should only ever have 1 assertion in a test. And you think, I can only write assert that 1 time. But that's a mechanical thing. Because in a previous test, we had assert that 1 time. But it was actually 2 asserts disguised as 1. Kids going to the movie and they have a coat, but it's really 3 kids. That was the kind of assertion that we had. Single test responsibility principle. Another important thing I did here was transform to identity. It's a variation of the transform before assert. I transform my persons into their full names, because that is much more useful to assert on, and it gives us much better context. So I identified an identity, and that it's not the database identity. So it's not a sequence of GUIDs, or GUIDs, however you pronounce it. It was the names. So the the identity is local to the test, because I may have another test that looks at the age of the person, for example. How much you need to do that, again, this again depends on the assertion framework. A rich assertion framework may have assertions that where you don't need to do this. If you have a simple assertion framework, then you may need to be creative in figuring out the identities. You could say that, well, you can just use toString, but toString is good for debug purposes. It's unlikely that toString will fit all the different kinds of tests that you will put on the person class. As before, important not to lose context. When you do transformations, always keep the context in mind so you don't reduce the test too much. Okay, one failure left. Person filters again. It filters away young people. Okay, and we expected something to be empty, but we have 74, 76, and 51. Obviously, these are young. You know, perhaps a test from the future where people live to 200. These are young. But this test failure is pretty nice. I mean, I can see that I expect nothing, no young people to remain, and I have a few young people to that are there. But I still want to know more about why this happened. The test actually doesn't look so bad. We have person filters without youngsters, and apparently the test considers youngsters to be 100, so this is just a test thing. People below 100 are young. And then we select their ages, and then we actually, from the ages, pick out the young ages, and then we assert that the youngsters is empty. So basically, our where clause should operate on an empty collection to begin with, of course. Is this good or bad? Is there a problem here? I'm stalling now because I have some time over, so I'm just thinking. Okay. No? Some? We can do that, sure, if it's an important thing. Anything else? It depends on if young here is if it matters for the test, or I mean, if we were to pass it. It depends on our test data, basically, of course. Anything else? So I could make a constant out of what it means to be a young person. Yeah, I could do that. So I can consistently talk about young people all across my code base. Yes, true. Well, we can toss ideas back and forth. What I was thinking about here is it uses link, and it's not very readable. To sort of parse in your mind and understand this test, you have to read the call that we're making, and then you have to figure out, okay, the select statement, what does it do? And then there's a where, and you need to look at the lambdas, and you need to try to mentally figure out what's going on. What do we do with this collection? And then on the assert, what does it mean that it should be empty? What is that correct with what we're doing? This is a test that is pretty hard to comprehend, I would say. I would like us to be able to write this instead. Filter without youngsters, assert that only old ones has none of age less than 100. This is a far more readable test in the sense that we don't have to parse a lot of link and try to figure out what empty means. And we can also have a good test failure from this, where we get expected no item with age less than 100, and we actually get the list of persons, and we see that, well, we have Diana Ross on 74, and Bob Ross on 76, and Ross Geller on 51. Even better would be if we didn't see the other ones, the oldies. What we have here is, does this exist in any unit? No, it doesn't. That would be very weird. No, what we have here is a domain-specific assertion. So we have created our own assertion related to our domain, which in this case was persons and age. Using the domain-specific assertions, we can have good failures because we can customize and control exactly how they fail, and we can have very comprehensible tests that read very well and are easy to parse for a human being. If we have an extensible assertion framework like any unit, that is of course very beneficial, because then we can do very flexible things, but we can also be very flexible if we have a primitive assertion framework by just creating helper methods. So if I create a helper method that says expect none of age less than, and then I pass in my collection, and then I pass in my age, and then that method can contain all the link crap that is hard to parse for my human mind, but on the test level I can just read the test and figure out exactly what it tests. So domain-specific assertions give us extra power in our tests. Okay, that was the final failure. Now we can go home. So just wrapping up, what we've seen is that we should avoid Boolean and numeric reduction. They take state and interesting data and interesting context and mash it together to true, false, or number, and makes our test failures pretty useless. We must study and make use of the assertion framework. Look beyond assert equals. See what does the test framework have that can make our tests fail even better. And we have talked about a number of patterns. Include as much context as possible in your failures, rich context that allows you to quickly pinpoint the cause of the failure. Transform before assert, make our data more assertion friendly. A special variant of that is transform to identity, where we pick an identity that suits the test case, and in doing that we get a lot of good information in our failure. The single test responsibility principle, where our test fails for a single reason, and it's not just about the number of assertions, it's about what is asserted and how can it fail. Domain-specific assertions for really good readable tests that also fail in a good way. Now, the value of good failures, of course, increases with the scope of the test. So as I hinted at before, if you have a really sharp, small unit test, as in the examples, it's pretty easy to figure out what went wrong. But if you have an integration test, UI test, then figuring out what goes wrong can be pretty hard and take a long time. There's one thing I haven't mentioned. I've talked about automated tests, and I haven't mentioned test-driven development once. No, it's a scandal. We need to talk about test-driven development. Test-driven development has this red-green-refactor cycle. You start with a failing test, you make it green, and then you refactor, and you start over. The beginning of the cycle, the first thing we do is write a test that fails, and at that moment we can inspect the failure. But as the first thing we do, so we get early feedback on what our failures will look like. And if we at that point see the error, the key was not found in the dictionary or something like that, we can immediately react and see that this will probably not end up as a good failure. In contrast, if you do test after, you won't know how the test fails, if it fails at all, because when you do test after, there's a pretty big chance or risk that you end up with tests that actually don't fail at all when things go south. So use test-driven development to look at the failures early on. And also bad failures also disturb the TDD cycle, the loop, red-green-refactor, because they slow you down. That was all I had. Any questions? Please then come up after the talk.